Hi, my name is Akhilesh Bachna. Today I'm going to talk about carbon dioxide emissions and what effect they are having on marine mammals, focusing mainly on baleen whales. I hope this presentation shows the severity of the changes happening in our world's oceans. So what is carbon dioxide, the culprit of this presentation? It's a natural gas made from one carbon atom and two oxygen atoms. This gas is produced by natural processes like breathing and is essential for plant photosynthesis. However, while CO2 is necessary for life, human activities, especially burning fossil fuels, cement production, and land use changes like deforestation, have caused atmospheric CO2 levels to rise drastically over the past 200 years. Here's a graph from climate.gov that shows you how much emissions have skyrocketed from before the 1960s to 2024. Um, you can see right past the 2024 mark, it's right above 420 parts per million. And if we take a look at the 1960s, right before the 1960s, it's right below 320 parts per million. This unnatural rise is having consequences for the ocean, as the CO2 that ends up there affects the acidity levels and it eventually warms it. I'll specifically focus on how these factors affect baleen whales. Ocean acidification. The ocean absorbs about 1/3 of human CO2 emissions. When CO2 dissolves in seawater, it reacts with H2O to form carbonic acid, which breaks down into bicarbonate and hydronium ions. The release of hydro oh, oh the release of hydronium ions causes a drop in pH, leading to acidification. Hydronium ions are just a name for H plus ions, so the higher concentration of H plus ions, the higher the acidity. Since the Industrial Revolution, ocean pH has dropped by about zero point 0.1 units, a small but significant shift that greatly affects marine life. Ocean acidification is measured by scientists using a pH scale, and you can see one on the right of this slide. So why is this acidity bad? Well, many marine animals build their shells out of calcium carbonate. The rising acidity levels are eating away the calcium carbonate shell, making it non-viable for life. This is decreasing plankton populations and petrobra populations. These bottom feeders are essential for larger animals like fish and krill, and once their population starts to decline, so do eventually marine mammals. This phenomenon is known as bottom-up effect. Bottom-up effect is when disruption at the base of the food chain ripple upward and affect large animals like the baleen whales. Let's look at a case study with baleen whales. These whales have baleen instead of teeth, which allow them to collect large amounts of krill and plankton. This is an example of how they look like, the baleen. Examples of these type of whales are humpback whales and blue whales. Like I said, they depend on krill as a primary feeding source, but for these krill to survive, they need plankton to survive. And as there's an increase in CO2 emissions, result in a decrease in pH, more plankton shall get weaker, and this reduces the plankton population, which in turn reduces the krill population, damaging up the whole food web, which is the bottom up effect. Since krill is not as available for whales, they have to expend much more energy to find sufficient food, which can have significant effects on their survival rate, their growth rate, and their reproductive rate. This shows the severity of how such small changes can affect such massive animals. Now let's now let's shift gears from ocean acidification to ocean warming. While ocean acidification changes the chemical composition of our oceans, ocean warming affects the temperature. But before we start talking about the effects of ocean warming, let's start with how CO2 makes oceans warmer. When we burn fossil fuels, for example, it releases CO2. This causes it to go to the atmosphere. CO2 is a greenhouse gas, which basically means that it traps infrared radiation. Instead of this heat energy just bouncing off the Earth and reflecting back into space, it gets trapped by CO2. This causes the temperature to rise, leading to a process known as greenhouse effect. A carbon sink is any system that is a man-made or uh, natural source that absorbs more carbon from the atmosphere than it releases. The ocean is the most stable carbon sink and does not get affected much by seasonality. It's a great carbon sink because it absorbs around 90% of excess heat generated, and this is due to water's specific heat capacity. However, as more and more carbon is released into the atmosphere, more heat gets trapped and the ocean begins to get warmer. And as the water gets warmer, the ability of the ocean to hold dissolved gases becomes worse. So it's like a positive feedback loop in the sense that as more CO2 is produced, the hotter the ocean gets, which leads it to having a less ability to hold CO2, which therefore produces more CO2 into the atmosphere. Without this ocean sink, our ability to combat rising emissions decreases, which will accelerate global warming. Here's a graph from the Environmental Protection Agency that shows the temperature anomaly over the years from 1880s to the past 2020. Baseline's at 0, and then we could see at negative 0.5. It was at negative 0.5 in the 1880s and at greater than 1.2 past the 2020s. And like pH, small changes in temperature has great effects on marine mammals. There are many issues that stem from ocean warming. Some of them include mass migration of prey, heat stress, habitat loss, and diseases. We spent a lot of time talking about diseases in class and habitat loss, so I'll focus on how ocean warming is causing heat stress and also that prey are now moving to cooler temperature waters. As ocean temperatures rise, baleen whales face a great crisis regarding heat stress. A baleen whale's composition is said to be made up of 50% blubber. They have evolved this way to provide insulation to themselves in climates with very cold temperatures. But as these temperatures rise, this can cause baleen whales to overheat. This is bad because in order to regulate their internal body temperature, they need to metabolize more energy. With the disruptions already in the food chain caused by the bottom effect and ocean acidification, marine mammals like the baleen whale need to hunt for more food and expend more energy trying to do so. And here's like an example of the blubber layer I'm talking about. The next one is about prey migration. This is another issue that stems from ocean warming, and many of the prey, like krill and squids, are migrating to colder locations. This is causing many baleen whales to alter their innate path of hunting. This is bad because baleen whales expend much more energy to hunt for food sources while also navigating them to uncharted territories. This makes it more likely for these whales to get struck by ships and to get tangled in fishing gear. Others may also get hunted by new predators that are located in these uncharted waters. This is placing a huge strain on some of these baleen whales that are already on the verge of extinction. I know this presentation is kind of depressing, so I added a picture of a humpback whale. But in conclusion, like not all is lost. We could try to reduce the effect of CO2. Some of the suggestions I placed in this PowerPoint are stuff that we can do on a personal level or government agencies can step in and also do. So first of all, we can reduce the production of CO2 or remove the produced CO2 so less of it ends up in the ocean. One way to capture CO2 emissions is to expand and restore trees and plants as they intake CO2 and produce O2. Another way is to utilize direct air capture methods, which can chemically scrub CO2 from the air and sequester it underground. And this is for a personal level. What we can do is that we can adopt the reduce, reuse, and recycle lifestyle and limit the usage of personal vehicles and rely on walking and cycling for shorter distances and opting for biofuels and public transport long distances. The government can also fund for more marine conservation programs and protect critical whale habitats. They can also invest in climate research and innovation to help save the baleen whale. Across all these challenges, food scarcity, physiological stress, and longer migrations, it's clear that the baleen whales are in the front lines of ocean change, driven by CO2 emissions, and I believe that we have to do what we can to reduce this impact on them. Here's all my citations, and thank you.